Doppler effect and sonic booms. The Doppler effect occurs when a source of sound is moving relative to an observer. This occurs when an observer is at rest and the source of the sound is moving, or the observer is moving and the source of the sound is at rest. A more complex case is when both source and observer are moving. We're not going to cover that here. Click here for a little video on the Doppler effect. The Doppler effect is the frequency shift of a sound due to the motion of the sound source or the observer. A source at rest emits a sound of a given frequency. We'll call that the rest frequency. If the source then moves towards an observer, the observer hears a higher frequency or shorter wavelength sound than the rest frequency. If the source is moving away from the observer, a lower frequency or higher wavelength sound is here. So here would be a person. The wavelength here, it's the difference between these waves here. That's quite small, so that means the frequency is higher. If you're over here and the fire truck already went by you, you have a longer wavelength and a smaller frequency. So our fire truck is in motion just like the last slide, and observer A in front of the fire truck hears a higher frequency sound than the sound emitted by the fire truck. Observer B behind the fire truck hears a lower frequency sound than the sound emitted by the fire truck. If the observer is moving with respect to the source, here we have two observers, things are a bit different. The wavelength remains the same, but the wave speed is different for the observer. However, the effect is much the same. The observed frequency goes up as you go towards a sound source and down if you go away from one. When the relative velocity increases, the difference between the rest frequency and the observed frequency increases. Consider a stationary car in a parking lot that is playing loud music, and the loud music is symbolized by those waves. Observer X is moving away from the car and will perceive a longer wavelength and lower frequency than a stationary observer. Observer Y is moving towards the car and will perceive a shorter wavelength and higher frequency than a stationary observer. If a source is moving faster than the wave speed in a medium, like a jet going through the air, the waves cannot keep up and a shock wave is formed. So here we have a stationary object, those are its sound waves. The object is moving slowly, right? The wavelength decreases. But if it starts moving at the speed of sound, the waves can't keep up and you get a shock wave, which is an extremely loud sound. And that's when an object moves faster than the sound barrier. And this would be a good video to help explain it. Shock waves are analogous to the bow waves produced by a boat going faster than the wave speed in water. So they would go on either side of the boat there. Aircraft exceeding the speed of sound in air will produce two sonic booms, one from the front and one from the tail.